Hello. Okay, this is the pre-stream at the moment. I don't start until 5 minutes time. Oh. I think this is the music in Kerbal Space Program. By the way, it's public domain. It's Kevin MacLeod. But yes, it's alright. So hello everybody. Hello. How's everyone doing this evening? Or this afternoon, or this morning, or whatever time zone you're in? Oh, thank you, Will, for hosting. Yes, you're... Okay. So yes, I'm making sure I'm playing public domain music so nothing goes wrong or anything like that. Hopefully. Let me check. I have no drop frames whatsoever yet. None, apparently. And it looks alright on my end. Alright, I'm just gonna slowly fade the music down. Hello! Hello, I'm Bill, or Ginger Bill as I'm normally known, and today I'm going to give off a little bit of a talk about something I've been developing, which is a compiler for a new language. So I'm going to give a talk about why I'm actually doing this in the first place, and then I'm going to show off a little demo. For people who have been asking, yes, I sound like a proper DJ. Actually, I used to be a proper DJ, if you wanted to know that. I used to do radio. So yay, there's that. So, let's get on with the talk. Let's get on my slides. Oh, I've got proper slides and all that, I know, right? Fancy. Whoops. There we go. I probably won't be able to see the chat now because it's been hidden up by this stupid thing on the left here for me, which is the slides. So hopefully, actually, you know what? You could just make this full screen and then hide everything for you. Like, you can get rid of the toolbars. Nope, that closed it. Technical errors already. Closed toolbar. Oh, whatever. Leave it up like this. This would be good enough. So, a new programming language. Oops, there we go. Yeah. So what is this talk? Well, today's talk, I am kind of explaining what I've been doing for the past nearly 2 months and why I've been doing it. I've been designing a new programming language which is meant to solve some of the problems that I've been having personally. Now, the question is, why was I doing this in the first place? So at the beginning of the year, I gave myself some New Year's resolutions for programming. So for new personal projects, I said to myself, I've got to start every new personal project in C, pure C. And reasoning for this is I wanted to figure out what I needed from a language. Now, I've been programming in C++ for a while. I'm not going to show off how long, probably over 10 years. And yeah, C++ is probably still one of the best languages out there, unfortunately, for low-level development and even high-level development. But it's still limiting depending on just of what it is. So I stuck with C and see what I can do. Now, there are a lot of scripting languages out there which help me to build tools and such, but I kind of came to this idea that most scripting languages are still not as good as C. The reason why that they are much better than C usually is because they have built-in garbage collection or stuff like that, so you don't have to worry about the memory. And then you've got a brilliant standard library usually. C standard library is dreadful. I mean it, you have to replace it. strings in C are null terminated, which is horrible. So that means that you can't do many string operations. Arrays aren't really first class. Functions aren't really first class. Then the syntax is all over the place, and so what? Yes, it's annoying. So they were my New Year's resolution, and my second one I had was if I physically can't do it in C, I'd have to meta-program it in. That was my other rule. So if I can't do it in C, I make tools to meta-program it in. They were my New Year's resolutions. So the reason why I kind of came to decisions, I was watching Sean Barrett's thing over a year ago, and he kind of gave some advice for writing small programs in C, and he was kind of like showing off his STB libraries and how he was making his own tools. And it's quite interesting to see how he actually makes these, and also showing them on stream and such. It's about a 90-minute video, I think. It's very good to watch if you want to do it. He did it about a year ago. But it kind of was, I was kind of hitting the nail at him. I was like, actually, he's kind of right in a lot of sentences. That actually, the language is usually not the problem, it's just usually the libraries. And a lot of languages are kind of still stuck in the 90s. They have not really exceeded further. The languages don't actually express more. It's usually we rely upon the libraries. So as a consequence, over the year, I kept adding to my own. And I made my own up, was the short answer. So these were the GB libraries. And now these had some default standard library stuff. I had some like ini file loading. I had OpenGL, platform layer stuff. Just the stuff as I was adding it as I went along. And it was very interesting to make, and I learnt quite a lot about library design. And I'm quite proud of my gb.h libraries, my single header file libraries, like Sean Barrett ones, or some of the other ones that are out there now, like Nuclear and stuff, for the intermediate mode graphics. And I think I'm quite proud of it. I think it's one of the best libraries out there, to be honest with you, for C, because it covers quite a lot of things, and it's a very simple library to use. I even have an extensive custom allocation system, which means you can say, hey, I can use this allocator instead of this one. You just pass it around and does whatever you want. I have concurrency stuff, so I had threads, mutexes, even actually better mutex in many cases than normal mutex libraries, because I do like a semaphore crossed with an atomic counter and stuff like that, and it gets quite fast. Again, there's loads of stuff in that library which I'm very proud of. And there's also got the platform there, which means I can create little teeny games and have a pixel buffer and OpenGL context, and it just works. And it's just all in one file, and I don't have to worry about dependencies. So why did I come to the conclusion about creating a new language in the first place? And why don't I use a language that's already been created? And the reason was I was getting fed up of creating all my metaprogramming tools. One night I was watching it was a Sean McGrath stream, actually. Sean McGrath, if you don't know, he's developing MOBA at the moment, and he's doing streams on Twitch, which is SSS McGrath. Some probably link to in the chat. And I was quite drunk, I'll admit that. I thought, fuck it, I can't be asked doing these metaprogramming tools, I'll just do one. I make a new language. And many of you might remember me, I went on to stream and I was quite, again, drunk, and started making a language. I started off with making the tokenizer, and even that was okay, actually. Half that code's still there, the rest of it's kind of junk because it was drunk Bill, not good. But yes, why did I not use my own language? And I did look at these as well. The main ones I looked at for ones I have were D, Go, Rust, Nim, and a few others. So we'll start off with D, the obvious one. My problem with D is it's got optional garbage collection, and the standard library has still got random bits which are garbage collected. So if you use them accidentally, you've used garbage collection, which is a big no-no if I want to high performance code. But you say, yes, you can disable that. That means you're now restricting yourself to the use of the standard library, which is kind of back to C++ mode. But also, kind of language was designed around garbage collection in the first place. So it's kind of, you're very limiting to it as well. And also the problem is, I think it borrows too much from C++, even its syntax. And its syntax is quite broken and very restrictive as well. You can't do much in the nature of the language. So there's not that. So the next language I looked at was Go. Now, I've been programming Go for actually about 2 years now, and I absolutely love the language. And I've been using it to make tools at work and such, and even made servers in it. So I think it's very well designed, it's very simple. But it is garbage collected, and you can't turn it off. The language is designed around it, and it needs it. So that is a big, big no-no for me already. The other thing is it's CSP-like concurrency. So it's got like you got coroutines or go routines as it's called, and it's got channels and whatever all flying around, and I'm not sure if that's even the best method, to be honest with you, for concurrency. I know Rob Pike loves it and all, that's why he added it into the language and all that, but I'm still not kind of sold on it. I don't know if it is the best. And also it's kind of it's also designed around the garbage collector as well, so there's that. And the second problem is there is no metaprogramming. I'm not bothered there's no operator overloading. I'm not really bothered that there's no function overloading either. But I can't do any metaprogramming, so I can't say, hey, generate this function for me, generate these data structures for me, generate a whole new bleeming piece of code for me, and introspection data without having to runtime. I want it to compile time and stuff. But again, Go doesn't have that. So the next most obvious one again is Rust. Now, Rust does a lot of things correctly as well. It's not garbage collected, and that's great. It's really high performance code, and what it's been designed for is high performance code, but it's also been designed for extreme memory safety. Now, personally, I don't give a flying toss about memory safety, really, because it's not really a problem for me. I know in some applications, for maybe, like for instance, like web browsers or banking software and stuff, memory safety is probably very, very important. But it might not be. It's still kind of not proven, and it's still untested a lot, and I'm not really sure about it. So, and also with Rust and stuff, it has all of its move semantics and its borrow checker and all that lot. So it kind of does a lot of its stuff at compile time. So it's quite clever and so forth. And also I have been looking at the spec and stuff, and custom allocation is very difficult. It kind of wants you to only use the default allocator, which is probably just malloc or whatever their version of it, the heap allocator. So if you want to use a custom allocator like a pool allocator or an arena or some custom free list or something, you can't really use it. It's not easy to use. So what about the rest? So there's Nim. I looked at that. It's got some nice metaprogramming features, but there's just, I know it sounds daft, the syntax is a bit off-putting, and a lot of its features are really off-putting. I'm like, do you really need that? It's a bit complicated. Fortran, I know you can laugh as much as you want. I know a lot of people who still programming in Fortran, even Fortran 77. They're mainly physicists, of course, but the reason why is that Fortran still has a lot of benefits for like parallelization and vectorization as well, and also the aliasing as well, aliasing problems with pointers and such. So Fortran can optimize better. But if you can design that into a new language, then great. Fortran's not there. Yeah, Abner's already saying Fortran 77 is big in NASA. Yeah, it's big in a lot of the physics community anyway. I know someone who's programming it, and they weren't even born in 1977. They were born afterwards, so it's older than them. Anyway, it's older than me as well. I'm not that old. But yeah. So, and my other problem was, why don't I just have a C plus an external metaprogram? Well, that's the problem I already had, and it was just a pain in the arse. Now, I'm not the first person to come up with this idea to make a new language and stuff. One of the new ones you may know is Jonathan Blow. Now, he's worked on games such as Braid and The Witness, two very brilliant games. I recommend them, you play them. And he's got a talk as well. This is one of his talk, and he's got many other demos and lectures and such about his ideas for a new language for games in particular, not just like general tools or daily stuff, but games in particular, and he want high performance. And a lot of my kind of needs and stuff kind of overlap with his, but some of them differ and stuff, and that perfect and its opinions at the end of the day. So if you want to watch this talk, it's quite old. He's got some new demos of the language in progress, so if you want to watch that, you can. I would recommend that as well. So, what are my goals for this language? I kind of want a pragmatic design. I want it be built to solve the actual problems that I have. And I don't want to be like C++, where it wasn't built for any practical reason. It was just because Bjarne Suttrup, or Barney Star Soup as I now refer to him as, because I can't pronounce Danish names. Sorry, Mikkel. Sorry, never mind. Because he just likes Singular so much, but he wanted it C syntax, so he added it into C++. He wasn't really trying to solve a problem. I don't want to go into that argument. I always want the language kind of not to hold back the programmer. Like, if the program wants to do something unsafe, let them do it. If they want to do something that you couldn't do in certain paradigms, like some object-oriented style programming paradigms or functional programming paradigms, where they restrict you into doing some certain pattern, I don't want you to be restricted. I want to just let you do what you need. But as a consequence, I want there to be high performance as well. I want to be able to get to the bare metal and get the performance I need. I would love this language to be faster than C. I know that sounds like, what do you mean faster than C? But actually, even if that means, like, from a programming standpoint, you write certain code and it will just be faster because of how you write it. Like in C, it's very hard to kind of like vectorize code. You have to rely upon either the compiler to do it, or you have to write it all yourself manually, and that's a dreadful pain. If anyone wants worked with like vector instructions and stuff on any architecture, you'll know. I also want this language to kind of be very simple to learn. I can keep the entire thing in my head. Like, I can keep the whole C spec in my head pretty much. I used to be able to. I can pretty much, but C++, I can't. The S-Fini stuff, most of that goes over the top of my head and I can't remember it. Go, I have most of that in my head and stuff, because it's a small language. Great. But yeah. So there's other things as well. I was talking about, I want to express the capabilities of modern hardware, such as vector instructions, concurrency, like multiple threads, atomics, etc., etc. I'm just kind of going on here. But yeah, I want to be able to express that in a modern way, because most languages still don't do that. I know there's many languages, like for instance, we'll say MATLAB, for instance, you can add two vectors together, but you have to rely upon the compiler to do that. You make sure it does the vectorizations correctly. Not many other languages do that. I kind of want to program that way. And the main two of the goals is, again, sanity of life. I want to just be happy when I'm programming. Sometimes when I program in C++, I'm just fighting the compiler. And I'm like pulling my hair out. I'm like, no, please, no. Just, if you know what I mean. And it's quite interesting, and it's good. And again, there's other things like C++ takes ages to compile. I've kind of got down most of my compilation stuff now down to about 3 or 4 seconds, even for like a 100,000 line program. But even that, I think, still slow. Like 100,000 lines, that's not much when you think about it. 100,000 lines, if each line's got about 30 bytes on it, that's 300,000 bytes, that's 30 kilobytes of actual like code. That's not much. And parsing that shouldn't take like 4 seconds. Computers are so fast nowadays that it should take like half a second at the most. 0.1 second, 0.2 seconds. Yeah, maybe you've got an optimizer doing there, so maybe add like another 0.2 seconds to it. But yeah, that's good. My other problem is I don't really want any external tools. Like, I don't want to have a make system. I just want to do it all in the language. I don't have to rely upon package managers or dependency tools or anything that's... I just want to do it all within this thing. Like, I have the compiler. Here's my file. Build it, please. This tells me... And this file will tell me everything you need to do for this program. That's what I want. I don't have to worry about make or CMake or Ninja or whatever the new flavour of the month is this week and that. And the second thing is, the third thing, again, of sanity of life, is refactorability. I am swapping code all over the place, and C++, the syntax changes. One big example of this is procedures or functions or whatever you want to call them. There's about 5 different syntax for functions. Like, you've got global scope functions, you've got internal ones, you've got lambdas, you've got closures, you've got function pointers, you've got... I think there's a few more I'm missing out here. There's a lot. And it's crazy. And you can't just cut and paste code into any place and it doesn't... You'd expect it to work. No, it doesn't work in C++. In other languages it kind of does, but it's still... I haven't really seen many languages that do that to the extreme. And then the last thing is metaprogramming. There's not many languages that do metaprogramming well. Lisp kind of did it back in the 50s and 60s and 70s and stuff, but even then it was like Lisp macros, and Lisp is, you don't really want to program in that in every day, especially for high performance code when it's not really that type safe. Well, it kind of is, you know what I mean, but some are, some aren't, and yeah, it has to be garbage collected. Metaprogramming is literally the fact that I can make a program to make another program. I can inspect variables, introspection, I can do like, hey, what type is this? Okay, if it's this type, do this, blah, 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 blah. Like, oh, these have these fields, these have these things. I can turn that field into a string, so I can output it as a string. And I could say, oh, I want to generate this data. You can see what I mean. Metaprogramming is extremely powerful. So they're kind of my main goals. So warning, now we're going to get to the opinions part of this little talk. The talk's nearly over, by the way. Got up another about 5-10 minutes, and then we're going on to the demo, which will probably take, I don't know, say 5 minutes. So opinions. Yay. So, in languages, there's usually error handling, and a lot of languages use exceptions for error handling. And I think exceptions is one of the worst ways to handle errors. The way I want to handle errors is say, if this happens, do this. Exceptions are like, try this, except no, do this, then finally do this, or whatever. Like, you don't know where it's happening, it's doing like a long jump to do something else, and like, it's crazy. And it doesn't work. I think software exceptions are dreadful. Now, I'm not talking about hardware exceptions. Hey, hardware exceptions are fine-ish. Yeah, they are fine. But software exceptions, I think, are dreadful and not a way of doing it. Now, I think Go does error handling correctly. Errors are just values, and you return them from your functions or procedures, whatever you want to call it. So Go has multiple return values. So you can have like 2 returns, like the actual value you want to return, and an error, like if it went accessible. So return this. If there is an error, handle it, then do whatever you need to do. I think that's the best way of doing it, and I think it solves error handling, in my opinion, like other ways. Now there's the other thing is RAI. Now, I know there are different versions of RAI, but I'm going to talk about like C++'s method. I know there's like Rust's-ish method, but I think it's kind of a really weird concept, because you're kind of linking construction and destruction, or the creation and deletion of a piece of data or an object with the actual object itself. And it's kind of confusing. Like, so if I want to create something and then destroy it, I have to kind of put it into like a wrapper class or some other function, like a wrapper thing of some sorts. And it's just like, no, I don't want to have to do that every time. Like, I just want to say, can you just, when it goes out of scope, do something, please? Like, I just want to write the piece of code right next to it. And I think defer or scope exit or whatever it has in many other languages like Go or D or whatever, or Swift, I think Swift's another one, isn't it? They do it correctly. So if it goes at the end of, hey, defer this statement till the end of scope. And for me, this personally solves a lot of problems that have RAI. So I say, create a procedure that goes, hey, initialize this. Is there an error or whatever? And then defer the closing. So another example of this would be for files, like open file. Did it open successfully? Great. Now defer the closing of file. So it's kind of a structured way of programming. And it's quite useful for me. Now, I wrote an article about this a long while ago, not that long ago, about this, and I'm just going to get it up for you. I didn't put this on the slide, I should have done. There you go, this is on my crap website. And it's on here, and I was talking about how I'm implementing in C++, because I actually prefer this method rather than constructors and destructors. I just want to write defer, and here's some example of the code, whatever. Just get rid of that for now, you don't need that. And my last kind of thing I don't want in a language, well, second last, I'll talk about the last bit in a minute, is I don't want any built-in like object-oriented concepts, because I don't want to orient around any concept, to be honest with you. I don't want to orient around functions, I don't want to orient around objects, I don't want to orient around anything. The thing I want to orient around is the problem, and I want to solve what I want to do. Sorry, I'm just reading the chat right now. It's quite funny. And I don't think that's good. I just want to let data be data, and I want to be algorithms. That's it. Sounds quite weird, I know. But I don't want to stop people from not doing that. If you want to do a V-table, that's fine. If you want to do like subtyping or some polymorphism or anything like that, that's fine. I'm not going to stop you, and in fact, I'm going to probably help you in some places, but I'm not going to make it like the default or make it too easy to do either. Like, you think this is the way you should do it. Okay, so the last thing, opinionated thing, is memory allocation. Now, I don't think garbage collection in any language should be, I don't think it's ever needed. Like, I don't think garbage collection kind of solves, and I'm saying that in inverted commas, certain problems. So when it comes to memory allocation, I kind of put them into two categories. I say deterministic and non-deterministic. And when I mean like this, I'm talking about either the lifetime of the variable, the lifetime of the memory, and the size of that memory. So if I know the size of the allocation and the lifetime of that allocation, then I call that a deterministic allocation. And I would say this is about 95% of all allocations. I know its size and lifetime. Great. That's fine. I can manage that easily. Then it comes to the other one. I don't usually know, might not know the size, like it might be some, depending on certain contexts, but I know its lifetime. This is again usually, like I would say, about 3-4% of the types. And again, that's not really a problem. I usually use like a heap allocator for that, or I use like an arena with like a temporary buffer or whatever the thing needs to become in. Then there's the, sorry there's no diagrams here, I only made these slides about a few hours ago. But yeah, then there's the other type, which is kind of, I know what the sizes I need to do, but I don't know its lifetime. So these are usually the rarest ones I have. And usually you can solve these with like maybe reference counting, but I try not to get into that situation, but sometimes maybe reference counting may be the best thing. Or if it's something like transient, like this happens only per slide, that I still kind of know the lifetime, but I know the limit of the lifetime, but not exactly, then that's fine. And then there's the last one where I don't know the size of the allocation and I don't know the lifetime. That's what kind of garbage collection solves. And my opinion is, you shouldn't get yourself into that situation. And if you do, then you've got other problems, in my opinion. It's not memory allocation that's the problem. Again, this is a very opinion data thing, and I wouldn't mind if you could actually have garbage collection in language and just turn it off and on again in certain parts, because you don't really care. But in general, I don't think it's ever useful. And there's loads of people say, yeah, it's great for games or certain uses. If we can get down it, like the pausing down to like 0.1 second or I wouldn't know, a few milliseconds, like, no, you shouldn't even have any pauses because of that. Like none of the cleanup. But let's get out of that now. So this is kind of the main points of what my language wants to be. I want it to be pragmatic design, built to solve the problems, and don't hold the programmer back. So, it's demo time. Let's get into this. And let's make this a little bit smaller. Oops. Is that a better size? There we go. Let's get rid of this. Oops. So this is my language. If you can see it. Yeah. And yeah, many of you may be able to see it's quite like JEI, like John Blow's language. It's quite nice to see. And I kind of just copied his syntax quite a lot because I don't really care. The syntax is not important. The other thing is I've kind of copied between like JEI, Go, Rust, and many of the like C and loads of other languages kind of merged into one. So that's what I've done. But yeah, sorry, someone's talking about garbage collector there, but I'll talk about it in the end, don't worry. Leave most questions till the end if you can. And I'll talk about that later. So the first thing is, if you must go with this, let's start from the top. So the first thing is this load directive here, this like load directive, so which is saying, hey, can you load this file in? Now this is not like include in C, which is part of the preprocess, and just includes the file as text. The compiler knows this and it will only import it once. So I could copy and paste this file multiple times, and it'll only import it once, load it once for me. That's great. Now these aren't technically modules per se or anything like that. I haven't got module support system in yet because I'm still not particularly sure about how to do it. Like I'm not really that sure yet. And I probably want some talk about that because there's a lot of things in there. So let's get here. This is the main procedure. Now again, all programs, like if you're used to C or Go or many other C-like languages, most of them have an entry point, and this is my entry procedure. This is the main procedure, and this is the entry point of my program. Now, here's some procedure calls, as you see, it's very C-like, and I'm just going to build it, and there we go. It's 0.4 seconds to execute. I think about 0.3 seconds of that, probably more, is Clang, building in Clang, because I'm building to LLVM bitcode, or LLVM intermediate representation. Then I pass it through to make it bitcode, and then pass it through Clang. So I'm only doing the front end, the middle end stuff. I'm not doing like the optimization end. I'm not bothering about that. But I could easily swap the back end in and out to whatever I need it to be, if it's C or some other back end. So let's look at this, and it's got printed out some lovely stuff, and you may notice some stuff already. So the first caller here is hello. And you notice Unicode is fully supported. I support Unity F8 completely in the language. And yeah, there's hello world, and I think that's world in Japanese. I think I done all the Japanese characters in here there just to test them. And it works, it prints it and stuff. And then I've got return here, return one. So this is the name of the procedure, and that there. So I'm going to explain all the syntax here, and there's a procedure syntax, and it returns one. And that function is called there. This underscore here is to say ignore the value, and that'll be explained later on. Scroll down. These are my lovely comments. So like C++, I've got line comments and block comments. But unlike C++, I can actually nest my block comments. So that's quite nice to do. I can nest them and it works absolutely fine. So don't worry about that. It's not even hard to implement, that's the thing. It's like 2 or 3 lines of code extra to add. I don't know why C++ never added it. So this is how you do variable declarations. And this is all in the global scope, of course, and you write the names of the variables you want. So it's a bit backwards to what you learned to see on the left, and the types of variables are separated with commas. If you want to do multiple, you could do single if you wanted to do that. Then the type is separated by a colon, which I call declare operator. Then it's the type on the end, so bool, and then I put a semicolon in, and that's the end of the statement. So I have semicolons in my language. I'm still not sure if I shall them, but they're not really a big problem for me. If I forget them, I find them very, very quickly, and it's not a problem. But also I allow in the syntax, I can also declare and like assign the values at once. So this is like box and cardboard to be bool, and then true and false. Now I'm just going to uncomment this first line here, and you'll see some clever things going on. I'm going to uncomment all of this so nothing goes on, and get rid of that as well. And you'll notice hello world is still being printed, and this is because this function is getting called a global scope. And you think, wait, what? In C you can't do this, and this is because this procedure gets run just before main does. So I have my own like runtime you can use, and you can call anything in here and it'll do whatever it needs to do. The order that gets called in is top down at the moment, but declarations at file scope are in any order. You can define anything referencing in anything order and it still work, but the order of execution is top down. So you can write hello world, this gets run at the beginning and it works. So if you need to load some other things that you may need to do, it's great useful, it works. Great. So let's get on to variables. And the variables first. Whoops, that's the wrong way on the list. So let's just run that and see if it works. Great, it does. So variables. This is how you initialize a value. And now, unlike C, all values are initialized to 0. This may be changed later on in the language. You'll be able to optionally make it not 0, but it will be 0 out by default. So that's how you declare it. So you've got the name of the variable, the colon, the type, and then a semicolon. You can also assign it as well with an equals, and then you got that as works. And you can do multiple declarations on one line as well. So you can do x, y, define as an int, then assign as 1 and 2. So that's great. And the cool thing is, I also have type inference. So I don't have to specify the type in the middle here. The right-hand side, the R values, we determine what the types of the L values are, the left-hand side values. So apple will be determined to be a boolean, banana will be determined to be an integer, and a world in Japanese, this is again, I've got Unicode support, don't worry about that, will be a string called world. Yay. Now, I've got some basic language type built into my language. I have a boolean. At the moment, it's 1 byte. I think I want to support multiple booleans and at different sizes and all that lot, but I'm just doing a byte at the moment because, to be honest with you, I can't be bothered to do any other size. And then I have some built-in integers, and these integers you have to specify the size. So it's 8 bits, 16 bits, 32 bits, 64 bits, or even 128 bits if you want. And usually these are done in software. Sometimes they're not, depending on the architecture, but it doesn't matter. They're sometimes useful, especially for storing time. And then I've got the unassigned versions as well. I've got floating point types. I've got an F32 and F64. At one point I had F16 and F128. Both of these were done in software, and I thought against them. I said, no, I'm not having it. But yeah, whatever you want. Then I've got the default ints. I've got an int and a uint, so an unsigned integer. So that's signed and that's unsigned. Now the size of an integer's got a very particular size. Unlike C, where an int in C is 32 bits, in my language it's the size of a pointer. Now the reasoning behind this is I want to be able to store pointers as in an integer without having to go to like a uint pointer or whatever. I don't know. I may add that. I don't know. But also that when you're optimizing code, you want your kind of the default type, like the integer type, to be register size. Now on virtually all modern architectures today, the size of a pointer is also the size of the register size. So that's kind of useful. So I'm just going to use it as that. So I know there's segmented memory, the old stuff like 16-bit stuff like that, where it's not the same size. Like some of it may be like 16-bit, but it's 32-bit pointers or whatever. But I'll think about that later on. I'm not worried about that now. So then I've now got raw pointer. Now this is equivalent to a void star in C or C++, and it's more equivalent to a C void pointer because all pointers can implicitly cast to that pointer. Now this is the oddball, and I'll explain why in a minute. Because all types you cannot implicitly cast between any other type. You must explicitly cast them. The only difference is the raw pointer, and that's quite useful in certain cases. And that. I've got strings built into my language, and strings are not C-style strings, but more like Pascal-style strings. They've got a pointer to the data and the length. Now these are mutable, like most things in my language. Everything mutability is the default. I'm not really sure about making immutability the default yet. I'm not really that sure, but I'll let it be a thing to discuss with some people. I don't really see the benefits of immutability by default as the default. I would rather make people decide it for me. Like, you can decide yourself. That's good. Now I've got two weird types. There's byte and rune. Byte is an alias for a U8. Again, it's a semantic reason. And then I have rune. Now this is an alias for an assigned 32-bit integer. Rune is, I nicked the name from Go. And I also, the name of my language, I forgot to say, but at the moment it's called Odin. So, yeah, Norse gods and all made sense. It made kind of topical sense. Now this is the used as a character. Now in C, a character is 8 bits, but that can only hold up to all ASCII characters. With a 32-bit one, I can hold all the Unicode characters, and that's great. And that's what I want. So now let's go to the funky stuff, funky types. These are all called untyped ones. Now, any untyped or unspecified type can implicitly convert to any typed type. So any untyped bool can type or explicitly cast, it can go to any other bool. So that's the reason why, as I want multiple bools, I want to leave them. So false and true could go to anything. An untyped integer can implicitly cast to any other integer. So if I write an integer constant of like 1, 2, 3, I can cast that will implicitly cast to either a byte or a I32 or an int or whatever, and it will just work. There's no conversions. And type float, like 1.3, that will go to whatever, floating point constant. You don't have to do a prefix or anything, it will just work. And this is all because of my constant expression library and stuff like. And again, there's all the untyped stuff. So, this is the basic stuff I'm trying to get through quickly because otherwise I'm going to be here for hours. So, there is now some 0 values for variables. So if you want a 0 value for a numeric, it's 0. That's dead easy. For a Boolean, it's false. For a pointer, it's null. For a string, it's either 2 question marks, and it's an empty string, or backticks, and this is a raw string, and I'll explain later what a raw string is. Now, there are compound types, or like I explained, but they've got a different kind of 0 value, and I'll explain later. So let's go on to the stuff. Now, there's the operators I have in my language, which you can basically do for most operator things. Okay? So I have like these honorary operators like plus a, that does nothing really, it's only applied to numeric types. Negatives, so, or minus, that'll be like minus a numeric type. This is a bitwise not, so it knots all the bits in the number, And then I have a Boolean not. So this can only be applied to Boolean types. And it will make it, if it's true, it'll make it false and false and true, whatever. Now I have the binary operators. So the binary operators I have are add, subtract, XOR or exclusive OR, which is with a tilde. Unlike a caret in C and C++, I'm using a tilde, and you'll see why in a minute. It'll make perfect sense. I've got a pipe for OR, I've got multiplication, quotients or division, modulus, or modulo or remainder, whatever you want to call it, and I've got this very clever one here, which I've nicked from Go, but the syntax is slightly different. It's called a bit clear. So all it does is equivalent to this, and this is great if you want to clear certain bits. I've got like a shift left and shift right, and they're good. I've got some very clever ones as well. This one is as an as. Now this is a typecast. This allows me to type, I have, hey, cast this as this type. Then I have transmute. Transmute is a bit cast. So if this is like an I32, I can transmute that to be an F32. So they have to be the same size, but that just means it's a bit cast of the bits. And it works. And that's very useful in a lot of low-level stuff that you may want to do. And the reason I can transmute is from, I nicked that from Rust, the name, and also it's not a common word to use, so you're not going to accidentally type it. And then I've got all the logical ones as well, so if this Boolean equals this Boolean, or Boolean doesn't equal this Boolean, or less than equal, whatever, they all work. So they're all the basic types in my language, so let's get rid of that and go on to procedures now. So procedures are here. Now the first thing you may notice is, these procedures, here's the main procedure for this procedure, this module I'm talking about, and then all the procedures are nested in between, and they're all use the same syntax. That's because you can nest procedures in this language. Or if you don't know what a procedure is, it's kind of like the main class of what functions are. Functions and procedures and subroutines are technically all different things, and I kind of went with procedure. Yeah? So you can just, it's the same syntax here, and I wanted a unified syntax, and I could place this add procedure, I could place it out here, and you know what? It would still work. And because of scoping rules, this add is different to this add, so if you were calling add in here, it'll get the first one. But if you were playing another procedure, call add, it'll get this one. That's great. So this is the kind of the syntax. You've got the name of the thing, and then you've got colon, colon. Now, in my language, colon, colon means declare and then define. And this will be this make more sense when I come down to constants. And then you define a procedure like this, you write proc at the front, and then you write the input parameters. So I've got an x, which is an int, and y is an int, and then returns an integer. And then I've got curly braces, just like C, and then I write return I, x plus y equals that. So if I now print an int, I should get 7, and as you see here, I get 7. And then I'm going to print a new line. So there's version 2 here. With the same syntax I have for declaring multiple variables the same line, you can do the same thing in procedures. You can go x, y equals int. You don't have to declare it for each variable, like in C or C++. I find this very useful because a lot of time I do have a lot of the same type in all at once, so I just say, hey, this works, and that works. Here's the pinnacle of programming. Usually we have like either factorial or Fibonacci sequence, and I went with Fibonacci this time, and it works. So recursion works, and the Fibonacci number, the 12th one, is 144. I think that's correct. That sounds about right to me. So there you go, it works. And again, it's calling from inside here, and you can see how it works. There you go. And it works, print int Fibonacci 12 and new line. Yay! So let's go another one. Let's go a bit more complicated. This one's called swap strings, and you may notice already this has 2 values for my at the end. Yep, I have multiple return values. Now this is needed for when I wanted like error handling and stuff, and I think multiple return values are very, very useful. And if you have multiple returns, you must enclose them with parentheses, otherwise you're going to have some syntactic ambiguity in certain cases. So this will swap strings, x, y, and you're going to swap it to y and y. So the strings hello and world, when they print them out, they're going to be world and hello. Great. And they print strings. Now there's a quirk of my grammar, which, depending on when the order of they get assigned, is that actually the right-hand side gets evaluated first, then gets evaluated to the left. So that means you can swap variables around just by going a, b equals b, a. And that works as well. And you can see here, it swapped it back to hello world. Great. So, other things, the procedures. You can also add some extra things to the thing. So these are called tags. I'm calling them, like, it's got like a hash here, so it's the hashtags. Hey, get it? Hashtag? Oh, no, mind. So yes, this is kind of what it is. And unlike C++, this is a mandatory thing. You're telling the compiler, I've actually profiled this and I actually want this to be inlined. It's not a hint, like inline in C. It actually says, no, this is actually getting inlined. And again, no inline is not a hint. It actually says, no, this is a no inline. And that's great. Now I've got some syntactic sugar now to show you. I was watching John Blow's compiler stream the other day, and I was like, how the hell has he seen my language or read my notes? Because I had this before he even did the stream, because I just nicked this from Haskell anyway, but I was like, okay. And for me, this kind of solves virtually all of my operator overloading problems. Well, there's another thing I'm about to show you, which I haven't shown yet, have I? Oh no, have I not shown it yet? Oh, I hope I will. I'll show it later in a minute, don't worry. I hope it's not missing. No, I haven't. I know where it is. Yes, fine. So you can do infix style. So this is equivalent to add 3 and 4, but it's infixed in the middle. So as you return, this should be 7. Yeah, you get 7. And then you can also do postfix style as well. So this is kind of like dot calls in many languages. And many people say this is unified function calling syntax, but I don't have methods in my language and I never will, so this is kind of different in my opinion. So you could write this like that. It looks like a dot call, but this procedure isn't associated with this type. As you can clearly see, it's just a number and it just works, and it's postfix style, and this is be very useful later on. So let's get on with constants. Constants are, again, you declare it with semicolon and then define it with the next semicolon and then define the value. So this is so constant, so the circumference divided by the radius and tau, there's your number. And these constants are different. They're not like defined in C with a preprocessed thing. These have scoping rules as well. So as you can see here, we've got tau, which is equal to here. This is great. And you know I've not specified a type. And the thing is, this isn't even typed yet. It only gets a type when you start using it, and it only in certain contexts. So when we use this, it will work in other places. And again, I can use a string as a constant. And then if this never gets used, it never gets added to the compiler. The memory never gets used for it. And then this is an untyped string type. If I want to explicitly type the type, I can just write it in between here, like with the same as the variable syntax, and say this is a tau32, this 32-bit number here, and this constant will mean this is now 32-bit. If I want to do the casting style, if I want like this number as this number, you can as well. Here's another thing, which is pi equals this. This gets all evaluated at compile time, so pi is actually equal to tau over 2, and it's not done at runtime, it's done at compile time, and it's calculated then. Because I have a very crap, but it's a big numbers line, kind of. It's not finished. I really need to make a good one, but it works, kind of. And again, this thing here, these all work, and they get here. Now, depending on whatever that's wrong. Sorry, that was, oops, I can't even type tonight, which is late. And look, that all gets calculated at compile time. So to prove this I'm just going to go say print f64a and then new line. And again, all things function scope, they compile in any order, it doesn't matter. So I can just write new line here. You can see it works. And I'm just going to do all these. And oops, what is it? Are these? What's wrong here? B is apparently an integer. That is correct. Wait, what? Yes, it is. Sorry, that's correct. That makes perfect sense. So let's just put that as an int. Sorry, that's me being a numpty then. And yeah, it does work. Does constants ever get called? No, it doesn't. And there you go. There's the values, and it works perfectly fine. But if we got rid of those things and actually put the values in there, that works. That's fine. And watch, turn this to an F64. It works. So it actually changes what you need to be. So it doesn't matter the types. Constants just work as numbers. Numbers work as numbers, if it makes any sense. So let's get that. And again, constants go to the default type, whatever that may be. So floats go to F32, ints go to an int, strings go to a string. Yeah. So let's go back up again and go to types. So we've already learnt this, that we've got types here, but there's also, you can do, instead of just inference from the writing value, you can do inference from other values as well. So this is the same as me writing int. And types cannot be implicitly cast. So even though this is a number, you cannot convert an x into an F32. So if I just write this now, there'll be a compilation error straight away. Saw how fast that was? Not even a second, not 0.1 second, it's so fast. Cannot assign x value of type int to an F32 in variable declaration. It's on line 190, column 12, so you can't do here. There you go, that's column 12. There's column 12, there, column 12's there, yeah. So that doesn't work, that's invalid. But you can do the bottom one if you cast it. So I kind of quite like this, especially with the short casting notation. It's quite easy to handle. That's great. So let's go on to the thing that if you're doing anything at any low level, you would be using them all the time, which is pointers. So I'm using the Pascal notation for pointers. So to get a pointer of a variable, you just write a caret before the variable. Now this is the pointer to z. If I want to dereference it, I just put that on the right-hand side. This is a very symmetrical operation, and as a physicist, I love symmetry. I absolutely love it. Even not just this sort of symmetry, but in like mathematics and all, it's lovely. So it's kind of nice to have. Unlike C++'s, this would be equivalent to that in C++, but it's like a bit confusing and like what? It doesn't make whatever. Like when I remember learning it, it was like it took me about a week just to learn it, and mainly it was probably because of the syntax, not anything else. And that's great. And you can see here this just works the same. And when we print it, we should get 1, 2, 3. There we go. Print there. It works. Yeah, you can see it. So the best way to think about this is a pointer to z if it's on the left, and this is z from a pointer. That's a good way to think about it. Like it kind of reads left to right. My whole language is left to right. It's great. Now, the only type that has implicit conversions apart from untyped types, I may have to change the name of them because they sound silly, are raw pointers. Now, you can implicitly cast any raw pointer to and from, like in C. Not in C++, but in C. And this is very useful. It's because, again, sometimes you want to do this, maybe something like low-level memory hacking or polymorphism or whatever. Like you want to do some sort of thing, and it's just useful. It's just a pointer at the end of the day. You shouldn't really need to have a type. You can strip the type away. So that's good and fine and dandy. Whatever. So let's get on to arrays. Now arrays are a bit weird, like in C. In C, when you define an array, let's do the same thing here. This is in C. This array would be like this. So the type of the size of the array is on the type rather on the variable rather than the type. I understand maybe why they did that. Like it's going to show like use, but that's a little bit confusing to me. And also with C, parsing is annoying because if any of you try to parse C or even just read it, in fact, you'll learn about something called the spiral method or the the clockwise method, and it just gets confusing. So I've just got rid of all that and say, no, you read it from left to right. So this thing here reads, you've got the 3 questions saved up, great. Oh, wait a minute, it's about halfway, you know. Got another about 20 minutes. Sorry about this. So this is an F32 array. So this is an array of 12 F32s. And to get the values of each of the indices, it's just like C, you write this, go index 0 equals 2, index 0 equals 1. Now I'm going to flag these up. Because arrays are known at compile time, you'll get compile time errors. Watch this, ready? Oh, index -1 cannot be a negative value. Whoops, that's wrong. Index 13 is out of range of the bounds from 0 inclusive to 12 exclusive. That's great. Other things is len and cap are built-in procedures. Now, I nicked this from Go. I may change it now. I don't know if I like it that much. But what this does is get the length of your array. And this is a compile time constant thing. So if I go, this is known at compile time. This isn't known at runtime, it's known at compile time, so it's great. Now, you may be wondering, why have I got a cap? And the size of cap is the same as len. And this may seem a little bit confusing. Why? This will make perfect sense in a bit. Now, I should note, I do not have runtime checking, bounds checking yet. It's not hard to add, I just haven't done it yet. But I do have compile time checking version for arrays. Now, arrays in my language, you can do multiple dimensional arrays, so you can just do this. You can go like array 2 of an array 3 of an array 4 of ints, and this will be column major. And this makes perfect sense for me because I can just write, this is the x value, this is the y value, and this is the z value. And it's all in column major. Unlike in C where it's row major. Now, again, there's debates or anything, but if you're designing language, I think just go with column major at the end of the day. It works. There may be still sig faults, mate, with what I'm going to show you in a minute. But again, this is now, again, when I'm saying left to right, everything's read left to right, and my whole language designed to be this way. It's been fast to parse. What you'll notice here is this is an array to a pointer of F32s. Yeah? Well, this is a pointer to an array of pointer of F32s. And the thing is, that reads lovely. It reads from left to right and you understand what it is. It's not like in C, where if you wanted to do that, you'd have to do that. And then for the other one, you would have to go like that. It's really confusing. It's a bit annoying is the short answer. So let's get on to the clever thing, which again, nicked from a few other languages. This is called a slice. Now, if you ever worked in Go or Python, you will have used a slice before. Now, a slice is an array reference. This means it takes a reference to an array. Again, that's what it means. But these are like runtime objects. So a slice stores a pointer to the underlying data. It also stores the length of the data that you're doing, how many elements in there, and then a capacity. Now, this is useful eventually, it will be useful for like if you want to do a buffer or a dynamic array or such, and that'll be very useful. So my slice notation is the same as in Python or Go. The first value is the low index, the second is the high index, so it's separated by a colon. So this means is we get this array here, and we're taking the slice of the indexes between 0 and 5, and then do that. There's my slice index, and that's the slice. If the first index is ignored, it'll be 0. That's great, and do that. Now, if you ignore the first two, this means I've now turned this array into an array reference, and this captures the entire size. So this would be the same as if I wrote 0 column, the length of array minus 1. That is what it means. Yeah, this is completely stolen by Go. Don't worry, I like Go, and I think this is useful. Don't. I know. But it's also stored from Python, so whatever. And slices have been in loads of languages before. Again, but this is the thing. Then if you put another parameter in, this would be for like capacity. So the underlying thing is starts at index 1, it goes up to the 5th index, and then the max is the 7th. So yeah, so that means it's got a length of 4 and a capacity of 6. So easy to figure out. You go 5 minus 1 is 4, 7 minus 1 is 6. Now I have a built-in procedure called append. Now this isn't like Go's where it will reallocate memory when needed. When it's ran out of space to allocate, it will just say it can't do it. Now, this means I'm now going to append a value 1 to the slice in here, this underlying slice, and this will show me if it's successful or not, like did it actually append it? And there's a boolean. I can ignore variables by just writing an underscore here. Like if I just want to ignore it, you do. Now you do have to actually say you want to ignore it. You can't just omit it like in C++, like there may be a value return, but we didn't handle it. I say, no, you have to handle it-ish, even if you were ignoring it. Great. Now, if you want to just copy, you can. Now, you can just copy 2 slices, it's a built-in procedure. Or if you want to just use memcopy, you can do that same as well. That is great. So if you were doing a memcopy equivalent, that's what it is in this language. Get a pointer to the first element, like so. And then get a pointer to the second element in that, and I want to copy 2 times this. I'm just cheating here, by the way. You probably don't know all the syntax yet. The size of the value there. That's the same as that, kind of. So let's go with strings. Strings are very easy. You can implicitly just declare a string, and you can also get a substring of this, and it's using the same slicing index. But instead of returning a slice, it returns a string. It's a substring. Great. Now this is one of my fancy things, and this is the one I took a month to actually implement because LLVM. I found loads of bugs in LLVM doing this. It's a short answer. This is a vector. Now this is a vector for of F32s, and it works just like an array as well. Like you can just access the elements and store them. So what's so special about this? This does arithmetic element-wise on it. It's a SIMD vector. This is literally a SIMD vector for you, and it's so easy to write. I could make this 120. I could make this 256 or whatever, and the compiler will figure out what it needs to do. The problem is that you still need to understand the underlying hardware because you don't want to cock it up. You want to understand what's going on. So I can just add vectors like other vectors. I can subtract them. I can even do element-wise products and stuff. These are the Hadamard product, or how do you pronounce that in French? Hadamard, there we go. That's much better way of saying it. Or you can even do that. I know I can't. I awful at French pronunciations. I'm sorry, Abner, who can actually speak French. I can read it, but not speak it. Another thing is I also have a built-in swizzle function, so I can swizzle the values around in a vector. So I can go, hey, I want to swizzle this around. This is 3, 2, 1, 0. So it's just flipped the order around. That's great. If you compare two vectors, you get a vector of Booleans. Now, this was a problem. It took me ages, and I was figuring out why I couldn't do it. In LLVM, this is highly undocumented, and it's very buggy. I just found loads of bugs doing this. Apparently, Booleans are packed, meaning this would be 4 bits, which means it had to be in 8 bytes. It wouldn't be like 4 bytes as you would expect. But in certain circumstances, it becomes 4 bytes, and then others, it just becomes whatever the hell it wants to be. It's like, what? So no one is kind of defined what they actually want to do. Yeah. Again, Swizzle, again, if you've ever done some D instructions, I'll show you one where there's an actual application for this later on. So there's that. So now let's go on to actually type declarations. If you wanted to define a type, it looks exactly like a constant, because technically types are constants, you can't change them. You just write vect4, define as type, and then write the type on the right-hand side. So this is a vector4, which is, again, vector4 as you want. Great. Got array 3 int, you can just do that, define that. Now I've got product types built into my language, it's like a structure. I have structures dead easy. I just have here, I've got an element list of x, y, 3, and z for a vector 3. Great. I can also do this for, I can do recursive ones, like I've got a binary node here, I've got a left and right and then the data. And this is the same format. Each line of this is the exact same form as a procedure or a variable declaration or anything, it doesn't matter. I can even declare the type of a procedure. This is the signature of a procedure, and you'll notice it's identical to if I even wrote a procedure that did this. The only difference is I've got rid of the body and just wrote type at the front. Works. Structures, I also allow them to be packed just by adding this tag on here. Like I've got loads of tag operations everywhere. So if I can pack this, now normally if I didn't pack this, the size of this would be, I'm trying to think, that would be 8 bytes, maybe? No, wait, actually, I'm trying to figure this what it is. The alignment that'd be 2, 4, 8, yeah, it'd be 8, wouldn't it? But because I've packed it, it's going to be 7. And there's a static assert here, which is another built-in procedure, but the size of the packed equals 7. Works, it's not a hist, so I say that's 8. Static assertion equals 8. And look how fast that was again. Fast that was to compile. Slow pots clang, not my end. Okay, so another thing is you can also declare within other things like this. Again, types are explicit, so you can't implicitly convert them. So if I said my int is a type int, I cannot add them together. Like if I do this, build that. This has already got previous declaration of z in current scope at this line here. Mismatch types in binary expression, int and my int. There we go. Great. So that doesn't work, but if you cast it, it works fine, and you have to use the typecast. No random implicit conversions from like a char to an int or whatever in C. That's just crazy nonsense. That's crazy source, that is. So let's go to one of the things where I want to explain why a transmute may be useful. Now this is kind of a transliterated piece of code from Quake 3 Arena. Now many of you may know the quick inverse square root function. And this is kind of what it looks like in my language. It's just a bit simpler. It's the same kind of line of code. It's no more or less. And you can see here I'm trying to do bit level hacks. And you can see I take the pointer of y, cast it to an int pointer, and then dereference it, do whatever I need, and then do it again. Not brilliant, but fine. So now let's convert this into my version. I just make it a little bit nicer to do. And hey presto, look, I don't have to declare them all at once. I can see it used to. That's fine. I can then just write transmute. And this does the same thing. This is a rare case of doing it, but there are other cases. Now in C, due to pointer aliasing rules and stuff, they do not like you doing this in the spec. And I think that's silly. I think a lot of the pointer aliasing rules in C are silly. But I won't go into that. That's another discussion for another day. So in C, the way to get around it is you usually write a union. So you write a union like this, like I and Y, and you do it that way. So yeah. Another thing I have are enums. Now enums, you just do it again, you write them like this, and you go, like write an enum like in C or something. But the way you specify each type is they've got a namespace of themselves. So you just write thing.apple. If I wrote apple, now it says undeclared type or identifier called apple. It doesn't know what it is. It's part of the thing namespace. Another thing about enums is I can also specify a size. Now I love this feature from C++11. I can just specify the size of an enum and go U64, and now this, you see the size of this is a U64. And again, I can also specify values here. So the first value is 3, then frog will be 4, tree's going to be 7, then tomb's going to be 8. So there's an implicit iterator going on as it goes along. And look, see, this should be 8. If I change this to 9, it's going to fail and such. Now at the moment, I don't have any introspection on these enums or anything, and I only allow integer enums. This will change eventually. I'll probably do something slightly different. I'll get to that in a minute. So the first thing I have is, I was talking about unions earlier, I now have untagged unions in my language. These weren't hard to add. And again, this is just like C. These are unsafe unions and they're untagged, meaning you can access any of the variables and the compiler won't know if that's bad or not. And that'll work, and compile it as an int, and it should be, there's 1, 2, 3, and I get this, I think that's the values printing out. Just to check, let's print that as base 16, and yeah, that's the value you get. Yeah, so that is what I expect it to be. Now you can manually tag a tagged union if you wanted to. This is what I have. This is actually kind of a transliteration of some of my code in my actual library, my actual compiler. So I have entities which explain, which are kind of structure around everywhere, saying this is an entity, that's an entity. Like I've got entities in my compiler, like a game or something. And I've got kinds, I've got a GUID, I've got the data for each of them. It's a constant, a variable. Is it visited a field using anonymous? The anonymous thing I'm going to show off in a minute. Is it procedure? Has it been used? Like, is it been used in the code? So I don't have to compile it if it hasn't even been used, unless you've told it to be. Is it a built-in procedure or whatever? There's a few more I've missed out, but and I love the data. Great. But I'm going to show this off in a minute, don't worry. Again, I really want tagged unions in my language, or discriminated unions, or whatever you want, like in Haskell or F# or whatever in those languages. I think tagged unions are brilliant, and it's the way I really like to do like hierarchical types or categorical types, or I don't know, not both, but like, you know what I mean, like subtyping in a way. This is what I kind of like to do. I prefer this to then rather like subtyping or inheritance or anything like that. That's the way I want to handle my code and represent it in memory. I'll probably go into a big discussion about this later, but it's all right. Okay, let's go on to the next thing, which are compound literals. Now, these were added in C99 and C++11, where you can define a type on the left, and then you've got the literals on the right. Now in C, you would, for this int, you would kind of like, you would just cut the brackets like that, but I want to be explicit about the type. It also makes it easier to parse as well, but shh, that's me being lazy. This creates an int. Now, I can also specify the values to an int if I wanted to. Or I'll put ... in there. That just means, hey, just figure out how many elements in here and create this int. This would be the exact same type, by the way, as if I wrote that. That will still compile. It knows it's that type. But if it's not a int4, so it's not the same type. Cannot assign value that, oops, to that. Now this is declared as a slice. So this is kind of the equivalent to if I wrote a 3 there, and then did that. That's equivalent to that. But sometimes you want to actually just declare a slice to a procedure, because the procedure may input a slice rather than an array. Now arrays get copied when you pass them procedures. They don't get a reference. You do a reference, you need a slice. So that's the same, and sometimes it's just easier to write. You may want to do this. You can do the same thing to vectors. Now vectors are a little weird. You either have to specify all the values or only one of them. And if you only specify one, this would be equivalent to me writing that. It gets broadcast to all of them. And that's what it does. It just gets broadcast. And this is like underscore PS1, whatever, you know, like that call in, like if you do it in C. Now, if you do 2, this will get an error saying expected either 1, a broadcast, or 4 elements in vector literal. Got 2 instead. Sorry, dot here is say it's the equivalent of me writing 3, but I don't know how many the types are, so just write it for me, please. And again, that's what it is. So if you want to do a special type like this, a vector, you can just do that. So like a structure as well. It works for structures as well. This is like if this was a structure. So a structure of like x, y, f32, that'll still work. And oops, what have I done wrong there? Ah, that's why, because it's a bit later on, but it works. Now, because of my strong type safety, I have to enclose that scalar value into this vector value. Originally, I had that working, but it was a horrible edge case in the compiler, and I didn't know if I could justify it. It was the short answer. Sorry if people are not understanding what a slice and array is. Again, an array is something that will allocate on the stack or global memory or something. A slice is like a reference to that array, or a reference to a piece of memory. That's what a slice is. It's not actually. It's just a pointer pretty much. It's kind of like a pointer with a bit more information. But yeah, that's what it is. So that's good. And then the last thing I forgot to write were character constants, which I call runes. And you just write a string of the character, then write rune tag before it. I forgot to talk about that. I forgot to put that in the demo. Silly Bill. But again, you can see this still works. And 5 times by 2, 5 and 2, the variables, and times both of them by 5, we should get 5 and 10. And you know what I get? I get 5 and 10, as I expect. If I change this to 50, I should get 50 and 10. Look, my maths works. My compiler works. What? Yay. Now, my procedures are first class in my language, and when I mean by first class, I can just pass them around like if there were variables, and so on and so forth. So I have defined this do thing. It requires a procedure of this signature, and I just do that. It just prints the value of this, whatever the signature is, and this is the value that I'm going to pass in is int, and it goes into there. It works, and it just prints it out. I should get 7. As I expect. Now, the difference here is the scope of a procedure is global scope. So the parent scope of everything in here is global. You cannot access like a variable from outside. So this will say there's no declared type called x. I do not have closures in my language. I don't know if I even ever will. It's one of those controversial things. I'm not sure if the benefits are actually that good for closures. So at the moment, that works. So the actual variable capturing is you can only capture variables in global scope with a procedure. You can capture all the types, like the constant things that aren't actually declared in memory. They work, but everything else doesn't. So now the syntax between a declared variable and an anonymous or a lambda procedure is slightly different. All you do is just change it from being a constant to being a variable. No, you have to put a semicolon on the end because this is a variable. It's not like my silly rules where I don't have to do it for here. I might change that. Can you just leave all questions to the end? I'm going to explain that in a minute. Actually, I'll explain Chrono Tracker. I'm thinking about also adding like functional things, like you may just write pure on the end and it'll make all the things constant, you can't change it. That's what I was thinking. And you're only allowed pure procedures inside as well. So if you want that functional style, it will work. But yeah, let's just do this. So just to show it works, it gets around here and we get -1, yeah. 3 minus 4 is -1. And in fact, you can also write an anonymous procedure here as well. So it's not a named lambda, it's just anonymous. You can just pass it through. Again, procedures are first class in this language, and it just works. There's many times I want to do that. But in C++, the syntax is random. In Go, the syntax between all this is all janky as well. It's all over the place. It's not consistent. Many languages don't have consistent syntax for this, unless you go into like a Lisp style. And it works. I think this is great, and it's very, very useful. I can write a quite functional style now, and I do like that. So now we go back onto strings and runes. To write a string here, this is an escaped string. So like in C, I write \, and this will become a new line. Now, I use backticks in it from Go, but I may change the syntax. I don't know if I like backticks. I may do what JI does, like here strings. That might be a better idea. But what this does is none of these variables are escaped, so it will actually just write it as pure text. So you can print it, see the raw it does that. And one of the biggest uses that I kind of love this to make crappy examples with is maybe shaders. Like this is a shader code, it's just a string. I didn't have to do this like I do in C with a new line every time and all that crap. It just works, it's just raw text and it works. This is actually a copy from some weird crappy game I made once. I'm just, yeah, it works. So runes are declared just like strings, except you write rune at the beginning. And there is a compile time check to see if this is a real one. If this is a rune literal, as it's called, like these are string literals and it works. So there's a Unicode for hearts, it's 2 love hearts. Oh, I love this. This is one of my favourite emojis now, if it's an emoji. Pictogram, whatever. If you want to be explicit about the Unicode parameter, you can just write /big U, and this is be a 32-bit Unicode character, and you just write that there. Lovely support for Unicode. Actually, what library am I using? I think I'm using the UTF-8 proc, which is using the Julia Lang one for thank. It'd be great. Yeah. Then there's this one here, is if you want to specify individual bytes, so /x for hexadecimal bytes, so these are individual bytes for this Unicode character, whatever. I can also support some weird character ones here for this this Japanese symbol. I don't even know what it means, someone will probably tell me. And if I want to do this, this could be a 16-bit one as well. This would be the 16-bit Unicode value for it. Again, the string ID is nicked from Go and all that lot. The rune idea is nicked from JI, because he just writes char in his language, but I'm writing rune because I may change it to char later on, I don't care. But yeah, great. And yes, Chrono Dragon, that is supported, by the way. Actually, it'll be the, that. There you go, that's supported. Yep. Actually, is that? No, it wouldn't be supported, because they've got weird rules. So let's talk about these built-in procedures now, which is about lying and sizes. Sorry, this has been going on for a long time now. Actually, how long has this stream been going on for? About an hour and a half. I'm sorry, thank you for watching so far, if you're still watching. I'm pretty impressed. So, we've got a lot to show on. Yeah, the reason why I'm using the hashtag keyword stuff is because I want to reduce the amount of keywords in the language. So the hashtag stuff isn't really a keyword, it says like, here's a hash and then get an identifier afterwards, and then it does whatever you need to do. So it doesn't use up a keyword. That's hopefully. So I want to, yeah. So now we've got different things. So here's the size of a type. I can even get the alignment and also offset of a certain value within this type. That's great. But if I want to do a value, I don't specify type. I have to do size of val, a line of val, and offset of val. And you notice what I've done here is t.b. That's great in my opinion. And I just get that, it gets the value and it gets the offset, and these will be whatever they need to be. So now let's go on to the new fangled bit, which is data control. This is the kind of the bits and bolts of whatever you're doing everywhere. So let's look at this for array. This is just a normal for loop. You look and see, you've got the sum, and we're going to print this, and it says the sum equals 12, as I expect. That's hopefully what thing's going on. There is no type of yet because I haven't got any of my introspection data stuff sorted out yet. I'm adding that when they get all the metaprogramming stuff. That's later. I haven't done that yet. I want the base language done. Here's another for loop, just like C, but I actually omit the initializing bit and the posting bit, and it works. Because of my syntax, I can say, you know what, just drop the semicolons from here and just do that. Again, nick the idea from Go, but I'm not sure if I want to do that. I don't think this is probably the best idea. So I mean, and if I drop even further, like 4 brackets, this is like for forever. I'm not sure if I should separate all these concepts out like Rust does, like have a range for iterable stuff, for a C-style thing, while for a while loop, and loop for while true. I'm not sure if they should be separate concepts or not, but yeah, it's one of those things. Yeah, it's an hour and 15 minutes so far, isn't it? Yeah. Yeah. Ooh. And again, one other thing I should note here is all... this here is a statement and it's not an expression. So you can't go like in... Sometimes when you do an expression, you do that. That is not allowed in my language. You would have to do that. It would have to be a separate expression. That's one of the things I should note. And the second thing is the values to these conditions here must be Boolean. You can't just have an integer here, because if I do that, it'll say this is a non-Boolean condition for a for statement. It's not working. Great. And this solves a lot of problems for me as well, so you have to be explicit saying it is the thing. Now, again, I haven't got any iteration stuff yet. That's not hard to add. Now, for an if statement, you can do the exact same thing. If condition is a Boolean, do this. And I'm just initializing variable. Now, I wanted to unify the syntax with for loops, so I put the initializer syntax here. I think this is now in C++ 14 or 17, something like that. I don't know why it took them that long. And it's not really that big of a feature, really. But you can do that. Because in C, the way you used to do it is you'd write int x equals 2, and then you'd do that. That's a little bit crazy, and not easy to write, and very error prone. So that's what you do here. And see this thing here, it's a different scope as well. This x here is a different scope to this x. So this x here is the scope of this if statement, while this x is the scope of this outer statement. Another thing is string comparisons are built in as well. So I've got either the string comparisons like these are done at compile time because they're compile time strings, or they are runtime things, and I've got a runtime library that does it all for me. It's great. Let's get to the cool thing now, which is defer statements. As you'll notice, in reading through this code, I can say defer this statement till the end of scope. So this says Japanese. This is Japanese and Japanese. And you notice here, Japanese, the English one gets called before the Japanese version. And that's because I defer this one before the other. Now if I defer 1, 2, and 3, they go 3, 2, and 1. So it's the same as scope rules. Like in C++, like these just added to a stack. So it's first in, last out. Does that make any sense? Defer is, I think, is much, much better than RAI or anything like that. And also defer, you just defer any statement. You can defer any statement whatsoever. So one of these lovely things I'm going to show off now is some of the context allocation bit I've got. And I've got implicit context allocator. Yeah, like JI, I nicked the idea, but I don't know how JI actually does it. I don't know if he passes it around through procedures or if he does thread local storage. I use thread local storage for that, but yeah. So I can say, hey, get the previous allocator, store my new one in, and defer whatever the previous allocator was until the end of scope. So I use my new custom allocator, and everything else works in here. So I defer a file. I've now got a file error, an open file, whatever, turns things like that, and a close file procedure. So I handle it. Have I got an error? If so, handle error. Then defer the closing of the file till the end of scope, and it's all gone together. Like there's the open, error handling, and closing all done. And look, rest of code here. That's dead simple to do, and it's clear and explicit. I'm not linking the opening and closing to a file with a wrapper class and all that nonsense. It just works. So it all works fine. For loops and stuff, this may be a good thing to do here. You can defer block statement, and you can also defer with an inside defer. So as you can see here, I've got dialect, exclamation mark, dialect, exclamation mark, dialect, exclamation mark. And to prove that is doing it correctly, let's do int I dialect 0, dialect 1, dialect 2, dialect 3, dialect 4, whatever, and it works there. And dialect blah, whatever blah is, which is, I'm deallocating this. I can't call it free at the moment because the C runtime crashes it otherwise. Whoops. But yeah, there's my lovely alloc. Again, conditions here, so if this is true, you can continue, and all the defers get called at continue. If I return, all the defers get called at the return as well, and if I break, the defers get called at the break. But this gets never happened, so it gets returned at the return. And because of return here, an early return, unlike functional language, you can't do early return, these things will never get called. Look, do you know they're not going to get called? That's great and handy dandy. So let's go on to the thing I implemented yesterday. I literally did this yesterday, so this was a late arrival to the compiler. Oops. One thing I also forgot to note was in procedures, if you have, I'll just write it here. So let's say this is a thing. I'm just going to make it up quickly. If I have an X and Y, F32, whatever. If I have a pointer to a thing, so that's a thing there. So let's say that's B. If this is a pointer to A, I can access the variables of B. This is equivalent to me if I was manually dereferencing and writing X. I don't see the point of there being a single thing because this helps me. It's late at night. I'm just a bit. Ugh. Where did you put my drink? Oh, I see it. There is. I don't think there should be a difference because you're usually passing those things by pointer. So why should you need to have a different syntax really? And there's a few problems this causes in my compiler at the moment. Not the actual dereferencing of like semantics wise, like with arrays and pointers and like I do pointer arithmetic with this, and it's a bit confusing. So yeah. Yeah, you can do. I've got scopex in C++. I did have this thing here. This is my version of it, at least. So there you go. That's the one I use for deferring C++. But yeah, that's what you can do. Access even pointer variables as if they were just non-pointed. So let's go to the fancy bit, which is using. So let's say this is the everyday stuff we have. Here's a vector3, and it's got x, y, and z. And now what I'm going to say is I'm going to use this variable in here, and I'm going to export all the names into this namespace of this type. So I can just do t.y. Note there's no y in here, but it's being used from here. So I can access it, and you can see it's got 456. 456 is there, yep. And you can see you can access it. You can also say explicitly pos.y, and you've got 456. And just to prove it, because it's all evaluated to 0, velocity is 0, so there's no problem there. You can also do subtyping, so this is, well, kind of a subtyping. I only implemented this yesterday. But yeah, as you can notice here, this is subtyping, and you can get all the values from entity which are being used. So .y still being used, and I'm going to set as what leet here, and it still works as you expect. And again, the velocity is 0. Now here's another complicated, another subtype you can do. Now let's go to the crazy shit. Oh yeah, the crazy shit going on here. Sorry for my language, if you're a younger viewer or whatever, or just offended by language. Well, whatever. I can do this onto Unix. So one thing I love in C, and I use this in my GB math libraries, is I like to do a vector like this sometimes, and like math libraries, and just be able to just say x and y. Here's the structure. In C, you would do an anonymous thing, but I think that's just a bit crazy, and I think you should just probably name it. You could also access it as an array, and you could also access it as a vector if you needed to. It takes up all the same amount of memory. And look at this, I'm going to use this on a pointer to it. So note, I'm going to make a pointer here, I'm going to allocate the memory for this thing here. Again, I haven't got a new or a allocate a type yet, built-in procedure, but I'll probably do that later. I'll probably do a lot of things later. But look, you notice this, I've just done dot. This is the same as if I had to write that. But no, I get my notation says you don't have to do that. But like that, and then look, you know what? I can just do that. So it's automatically dereferenced it, gone all the way through, gone all through the pointers, and it's working. So I can also go explicitly with the _x, go with a dot here, or the really long version here as well. So it works. And you can see it's got 1, 2, 3, 1, 2, 3, 1, 2, 3. So that is the end of the basic demo. So there's the nice, clever things. Let's just do this. This is, again, it's not a game, but let's run that. There we go. There, look, there's a square, colourful square moving around with my arrow keys. And yeah, this is pretty snazzy, if I say so myself. This is an amazing game. And you know what the best thing is? This is an OpenGL window with an OpenGL context running in a Win32 window. Yes, I interface with C. This is my Win32 library. Yeah, look, Win32. Look, I've got all the OpenGL context stuff, and you know what? It all works. It's brilliant. So let's just go to the game code. It's not a game yet, but it works. And there you go. It's great. Yeah, look. So I've got all these different procedures. Look, I've even used the cool things like I can just set the query performance thing at the beginning of the runtime. Don't have to worry. I've got all this procedure stuff. I've got my own structures. I've got make things here like error handling. I've got you can just pass a procedure here. Like I've got a window proc there, and wherever the hell that window proc is, and yeah, this all works, and I'm calling C runtime, and I'm calling Win32, all that works. I've got all this code here. You can see it all works. This looks just like normal C code to you. I'm using all my code here, it all works. Swap buffers, C things, run the game. Got an inline function here. In fact, I can just swap this code in here just to prove it. I can put that procedure here, still compile and run. Look, so that recompiled it, and it still works. Got the furs, I've got everything I'm using in part of my languages works, like ignoring the features, for loops, key pressing, the OpenGL I'm using. Oh, look, there's a built-in procedure here to do all my stuff. It works. Okay, I can make this into a lambda if I wanted to. Hey, it works. I think this is great. And for what I've done already, and it's in like not even really, it's about 2 months, I think. Probably 2 months to the date, actually. It's been brilliant. And I'm really quite pleased with what I've done. And I think even this is already better than C. Just to prove that I can do built-in stuff, if I go into Win32, you'll see all the procedures are marked with foreign, meaning they're foreign function interface. And I'm relying on Clang at the moment to do this for me. But it works. And I'm quite happy, and it's quite useful. And also you can foreign function, again, declare a procedure in the middle here, and it's great. And yeah, so at least that works. At least I know I haven't got a game. I wasn't fancy. I didn't have a Gallagher clone like Jonathan loaded, but at least I've got a colourful square going around the screen with my things. Yeah. Yeah, at least this works. So, shall I leave it to question and answers first now, or do you want to see the runtime code? There's the runtime code. There's some of my, there's my mem copy, there's my mem move, there's the allocation stuff. Yeah, there we go. Shall we go to question and answers now? So, Q&A. Oops, shift 11. What is it? Was it shift F11? There we go. And there we go. So questions, please, like Q colon whatever. Can you generate a DLL and get proc address from it? Yeah, it's just using Clang. I mean, the back end is Clang, so you can just use the Clang linker to do it, and it's already done. Yeah, just prefix whatever you want. We'll use create operators for every SIMD operation, aka will you have love. The operators for vectors are whatever the underlying type is. So if it's an int, you can use remainder int, whatever you like. That will all work. If it's a floating point operations, whatever the underlying thing is. I only allow numerics and booleans at the moment, for technical reasons mainly. I may add others later, but there's no real reason. It is a direct mapping to the machine I was trying to do. Other questions. Can you add... What does it add? Maybe, yeah, I may add... Professor ROI and ROI, yeah, I may do. I'm not about... Yeah, I might be start doing it. It might... Yeah, that's kind of valid syntax, but the way the valid syntax for... that works. That's equivalent to that at the moment. So it evaluates the dereference before it evaluates the pointer. It's a quirk of the syntax. So yeah, that would be valid syntax. So yay! Oops. Yeah. Oh yeah, I just installed Go, didn't I? The other day. There was for some reason my computer today decided to not boot up properly. So it said, "Oh, we're going to delete all the problems that caused the problem," and it deleted everything. And I mean everything, deleted every single application except on all Microsoft ones. So I've had to go and install Visual Studio, Go, everything today. Just do it. It's horrible. It's a new computer as well. What is doing it? What other questions have you got? So, yeah, this is the casting notation in C. I do not allow that. My casting notation is that. Yeah? You write an as. Oops. Has anyone interested in... is Odin self-hosted? What do you mean by that? The compiler understands itself, but I build to LLVM, and then I... what do I do? Yeah, I build to LLVM, and then the LLVM builds what I never need to do. So I do all the front end and middle end stuff. I don't do the optimization of back end stuff. I don't convert to assembly. I could do. I actually have most of the code to do it already, but too lazy. Next question. What's this? That's a library thing at the end of the day. It's not a real language feature. Yeah, sorry. Gary Johnson again with the vector thing is all vectors are kind of mappings to vector things. So if you have AVX5112 enabled in the compiler, so if I just went, God, I can't think about how many would that be? That would map to an AVX512 register. Yeah, it is a direct mapping to registers. It's a way of doing it. So yeah. Are there any other questions? It's technically already on Android Network. Shh. But, debugging information, I'm not adding it yet. I need to figure out how to do it, because LLVM is a pain in the bum. It took me, I wasted a month just on LLVM. So hopefully I'll probably be able to get like dwarf info from Clang and stuff like that, but I don't know, it's not a priority yet. At the moment you have to use printf debugging, unfortunately, or print whatever debugging. How does my libraries work in Odin? At the moment it's like a better version of C. There are no like namespaces or things. It's just you just load a file. So as you saw in here at the top, oops, daisy. So Win32 Odin here, this just loads the file in, and just only includes it once. So it loads it and kind of adds it to the abstract syntax tree for each file, and does it that way around. And so it's okay. But yeah, Odin compile itself yet? No, yeah. I have enough to do that. The language is complete enough to actually make the compiler itself again, but I don't want to because there's a lot more I want to add. Can you play with this yet? Not really. I wouldn't want you to, because it's not finished yet, and I may ask for a few people to help me out on this or something, or just for a few things. But yeah, it's not brilliant yet. So I just go back to the demo code. Yeah. Any other questions while I'm here? What time is it at the moment? Actually, what is the time? Shift F11. Oh, it's 11 o'clock. That's not that bad. I know I probably will have a lot of volunteers. I don't really want a lot of volunteers. I probably want like two people at the most. 2 or 3, yeah. But yeah, this is great. The whole thing, the compiler's written in C++, not C, because I have to. I'll show you actually. Let's just go to the parser as a big example, because I don't have tagged unions in C. This is how I've done tagged unions. Do a massive macro that does all this. This is a macro for a tagged union. Still going, and then I create the union types, create the string names, and then I create the structures with all these macros. If this was just a built-in type, this would be much lovely. This would be so much nicer. The horror of macros, that is, the horror. But yeah, this is all works fine and dandy. But that's what I use. I use this all the time. Like entities do the same sort of thing. The only difference is they don't do it like manually where I've done there. Like there's my entity class. You can saw that was the same code that I had in my demo for, was it usings? No, it wasn't. It was types. Where is it? Here. So you can see it's a similar code, isn't it? The thing I said here was me using using. When if I applied using to this thing here, it would make it equivalent. Yeah. There was some other data here I had earlier today. I've just got rid of it all because I've been simplifying the compiler down like a bunch. But yeah. Yeah, forcoder.odin, yeah. Again, it interfaces with C, so I'll be able to interface with the forcoder library dead easily. It's not... If you've got DLL, just load the DLL in. Like, I already do that with some other stuff. But yeah. Also, the name Odin, I'm going to have to change it, because apparently someone told me there's another language called Oden. I'll change the name. I don't know what to name it yet, but names aren't important really at the end of the day. How long? I should probably put this stream on for another few minutes. I'll take some last questions then, and then I'll finish up. That's all right. Yeah, well, it'll be the end of the recording stream anyway, at least. But okay. And then I've got some snacks to eat before I've got some supper. I've got a Twinkie actually. Don't usually have them, and you don't usually find them in this country often, but not brilliant. Twinkies, yeah. Coding, oh, that's brilliant, Malin. That's absolutely brilliant. I haven't got exporting yet, and the name mangling is weird. So this is the demo LLL. This is, oops, not that one. That's the XC. This is the bitcode that I generate, and the name mangling is a little bit weird. So types. This is the types procedure and the procedures underneath, and there's a dot underneath it. This is to make sure that you don't have scope problems. So there's some weird name mangling going on in certain places for nested things. But everything else, there is no name mangling. Like variables has got like this. Well, it's the same rules as C. But if it's nested like this was, yeah, there'll be stuff like that. It must be Boar, yes. Okay, I'm not going to explain that reference. That was one of my drunk compiling streams, long one ago. Call it Kate. What the language? But isn't Kate a text editor? Oh yeah, someone said in the chat that says yeah, it is. Bush, Kate Bush. Oh yeah, I'm not going to sing Kate Bush. I'm not drunk tonight, so I'm not doing that. And also, my voice is too deep for Kate Bush. No. No, I'm not drinking anything. Not doing it. Call it E. So we've gone from C to D, now to E. Well, the thing is, But yeah. Again, I started this thing when I was drunk. What names? Better names for programming languages. Laser, yeah. Looking also. Oh, okay. Thanks, William Bundy. Yeah, pretty cool as is. Whatever. Demon Lord. Oh my god, that's not that bad. Lord actually is probably a better way. No. Can't be confused with the singer, wouldn't it? Go to F. Never mind. No, F exists. F sharp as well. Z? Does G exist? GB? No, GB. That's not good. That's the country. Again, names are completely not really important, and I don't want you to do bike shedding over this. Yeah, there's some. You can see all the code. And this is how I have to generate it. So it's kind of like a high-level assembly language. LLVM IR is. But again, I didn't use any of the LLVM libraries, by the way. I had to just generate them myself because LLVM doesn't work on Windows very well. In fact, it just probably doesn't work at all. Thanks, LLVM team. Yay! So I have to make my own SSA tree. So I have my AST, abstract syntax tree, which gets semantically checked and gets all the symbol tables generated. Then I make an SS tree, a single static assignment tree, which then gets converted into LLVM. I could convert it to GCC code or whatever other one there is, and that gets done. Don't name it too hard to Google. Well, I was thinking I was going to name it like $dollar or pound sign, actually, @pound. That sounds like a brilliant name for language. Not hash, that's probably brilliant, yeah. Some great things for, I could call it hash and then tag, that'd be a great name. Yeah, some name language Go, and everyone writes Golang now just because it's easier to write and like search for and stuff. But yeah, so I think this is going to be the end of the stream, or the official recording of the stream. So thank you for everybody for watching this long. It's been going on for nearly 2 hours now. So thank you so much for watching. Oh. So I go watch another stream now. Be it Bundy, Strange, Zach, or I don't know, whoever's streaming at the moment. See ya, bye.